Objectives for 3.3. Number 1, use long division to divide polynomials. Number 2, use synthetic division to divide polynomials. Number 3, evaluate a polynomial using the remainder theorem. And number 4, use the factor theorem to solve a polynomial equation. Okay? Do you remember any of this stuff from Algebra 2? Good. Let's work on it. X squared plus 10x plus 21 divided by x plus 3. Let's do this with long division. Okay? So remember, long division, what we're dividing by goes inside, what we're dividing goes inside, and what we're dividing by goes on the outside. And what we think about is just the first terms, right? That's all we have to pay attention to. What is x squared divided by x? So we write that over the x term, and then we multiply. X times x, x times 3. And then we subtract. Now I put a subtraction sign by each term, so I remember to subtract each term, right? Otherwise, if I just put it in the front, I'll probably remember the first one, but probably won't remember the second one. Okay? X squared minus x squared, 0. 10x minus 3x, 7x. And then bring down the 21. Now again, we just look at the first terms. Divide the first term here by the first term here. 7. It goes above the constant. Now multiply. 7 times x and 7 times 3. And now subtract. Zero. So what's the answer? X plus 7. Let's go and do this problem with synthetic division too, because I can. Do you remember the rules about what we can do with synthetic division and what we can't? We can only divide with synthetic division if what we're dividing by is x, is the highest exponent. X plus 3, x minus 5, 2x plus 4, but not x squared anything. Okay? So remember, if this is what we're dividing by, negative 3 is what goes on the outside, because this is a factor and I need to put the 0 on the outside. So I would set this equal to 0 and solve by subtracting 3. That's how I know it goes on the outside. A 1, a 10, and a 21 goes on the inside of our synthetic division bar, which is basically an upside down long division bar, right? Underneath our constant goes our remainder box. Okay? Remember, the rules are we bring down the very first term. No matter what it is, I just bring it straight down. And then I multiply these two and write it right there. And then I add to get 7. And then I start over. Multiply these two. I write it right there. And then I add. If this is my remainder box, the term right beside it is the constant, and the term right beside it is the x term. So this translates into x plus 7, which is exactly what I got when I did long division. Does that make sense? Okay. Let's do another long division problem. 6x to the 4th plus 5x to the 3rd plus 3x minus 5 divided by 3x squared minus 2x. So when we set up our problem, on the outside I have 3x squared minus 2x, What do I have on the inside? Why did you add that? You have to have all of your terms represented. If you start with an x to the fourth, you've got to have a place for an x to the third and an x squared and an x and the constant, don't you? Okay, good job remembering that. So then we need a plus 3x and a minus 5. Yes? Okay. Now this looks messy, doesn't it? It looks long and hard, doesn't it? But I only look at the first two terms. That's all I'm looking at right now. What is 6x to the fourth divided by 3x squared? Well, 6 divided by 3 is 2. X to the fourth divided by x squared is x squared, right? So 2x squared is going to go above the x squared term. Now multiply. 2x squared times 3x squared, 6x to the fourth. 2x squared times negative 2x, negative 4x to the third. And now subtract, right? Now why am I going to change this to a plus? Because I would be subtracting a negative, and I don't want to just put two subtraction signs there. That's confusing, isn't it? Okay, so what do I get here? That's 0. What do I get here? 9x to the third. I want to bring down the rest, don't I? Okay, so plus 0x squared plus 3x minus 5. Then I start again. Divide this first term by this first term. What do you get? 3x, good. It goes above the x term in the problem. And now I multiply. 3x times 3x squared, 9x to the third. 3x times negative 2x. Good. And now subtract. That's 0. This is and then bring down the 3x and then minus 5, right? Plus 3x minus 5. Now I just start all over again. 6x squared divided by 3x squared, 2. It goes above the constant in the problem. Now I multiply. 2 times 3x squared, 6x squared. 2 times negative 2x, negative 4x. Subtract. This is 0. This is start over? Why not? Yeah, first of all, I'm at the end. I don't have any more place to put answers at the top, right? And when we do long division, we're not going to add a decimal and add zeros like we do in regular, like, whole numbers, right? This is our remainder, isn't it? So plus our remainder, 7x minus 5 over what? Yeah, what I was originally dividing by. That's right. This is my answer. Now, why did I not leave space over here for us to do this problem with synthetic division? You can't, can you? Tell me why you can't again. There's an x squared in what I'm dividing by. That's absolutely correct. Any questions about that? I want to do one more synthetic division problem with you just to make sure that we're good with that. Okay? 5x to the third plus 6x plus 8 divided by x plus 2. So remember, this is our factor, or it's what we're dividing by. So in order to get our 0 that we put on the outside, what do we do with it? I solve for x, so what goes on the outside? negative 2. Okay? What coefficients go on the inside? 5, 0. Once again, why did we add a 0 right there? If I start with an x to the third, I've got to have an x squared represented, an x, and a constant. Everything below it, right? So here's my x to the third. I don't have an x squared term, so I need one. The only thing I can add that doesn't change the value of the problem is a 0. And then I have a 6 and an 8. Got my remainder box under my constant. Whatever that first term is, bring it straight down. Multiply. Write it here. Add. Oh man, I wrote it in the wrong color. I know you don't care about that. Multiply. Write it right here. Add. Multiply. Write it right here. Add. So how do I write my answer? This is the remainder. This is the constant. This is the x. And this is the x squared. 5x squared minus 10x plus 26 plus negative 44 over x plus 2. Can somebody else tell me the other correct answer? Do you see the difference? And do you see why they're the same? Okay. I honestly don't know which way your computer will want it. So if you try one of them and it doesn't work, try the other one. Okay. How are you feeling about long division and synthetic division in our objectives for today? Good? Okay. There's two more objectives, talking about remainder theorem and talking about factor theorem. So I need to tell you what both of those theorems are. We're going to write them down so we have them in our notes. Okay? We'll start with the remainder theorem. If the polynomial f of x is divided by x minus c, then the remainder is f of c. So this problem we did just a second ago, x squared plus 10x plus 21, we divide it by x plus 3, right? What this is saying is if I divide this polynomial by this one, the remainder that we got of 0 is what it's going to be if I plug negative 3 into the polynomial. Let me show you what I mean. Here's what we had, x squared plus 10x plus 21. And we divided it by x plus 3, and we got just straight up x plus 7, no remainder, right? So what this theorem says is if I take x of negative 3, right? Do you see where that came from? If I take f of negative 3 and substitute it into this equation right here, so like negative 3 squared plus 10 times negative 3 plus 21, the answer I get down here should be the remainder I got over here. Well, what remainder did I get over here? 0. So this value right here should be 0. Well, is it? 9 minus 30 plus 21. 9 minus 30 plus 21? 0. That's the remainder theorem. Does that make sense? Okay. The other thing that we want to talk about is the factor theorem. That's our last objective for the day, is using the factor theorem to solve a polynomial equation. So in order to be able to use it, we got to know what it is. Okay? So here is the factor theorem. So first of all, we're going to say let f of x be a polynomial. Okay, so there's two parts of this. Part A, if f of c equals 0, then x minus c is a factor of f of x. And part B says if x minus c is a factor of f of x, then f of c equals 0. You see anything interesting about those two parts? Aren't they just like backwards of each other? It's saying if f of c is 0, if you put in the value of c and you get 0, then you know that x minus c is a factor. The second part says if you already know x minus c is a factor of 0, then you also know that f of c is going to equal 0. Does that make sense? Okay. So, 2x cubed minus 3x squared minus 11x plus 6 equals 0. That's the problem. Okay? I'm going to tell you right from the beginning, 3 is a 0. Okay? That's given to you. 3 is a 0. Okay? Well, if you know that 3 is a 0, what else can you know about this problem? Because maybe I'm going to ask for the factors. If you know 3 is a 0, what's one of the factors? X minus 3. Now, how many more factors are there? Remember the fundamental theorem of algebra? Highest exponent is how many solutions you should get, right? If you have 3 solutions, how many factors do you have? Most of the time 3, right? Most of the time only because if it's the same 0, you might have to multiple factors, multiplicities, kind of things that we talked about the other day, right? Okay. So I got to find, if I'm trying to solve this, because that's what I'm trying to do, right? Because that's what our objective says, use the factors theorem to solve a polynomial equation. I'm saying, here's my polynomial equation that we're trying to solve, but I'm telling you right up front, 3 is a 0. Well, if 3 is a 0, we know that x minus 3 is a factor. Yes? How are we going to find the other factors? Yep, set it up. 2, negative 3, negative 11, and 6. Bring down your 2. Multiply your 3 times 2 and get 6. Write it beside. Add and get 3. Multiply your 3 times 3 and get 9. Write it here. Add and get negative 2. Multiply 3 and negative 2 and get negative 6. Write it here. Add and get 0. Did I know that should have been a 0? Yes, right? It told me 3 is a 0, so that means I'm going to get 0 as my remainder. So what do I have left? Convert it back to an algebra sentence. 2x squared, good. Minus 2. Now this is somewhere we're trying to solve, right? How should we try to solve this? Well, that's a trinomial, isn't it? We know how to factor a trinomial, so should we try to solve it by factoring? Well, what's AC? -4, and what's B? 3. What multiplies to be -4 and adds to be 3? How about 4 and -1? Will that work? Well, my leading coefficient is not 1, so I can't go straight to my factors, but I can split my middle term. What did you say, 4 and -1? Yeah? Well, there's 4 terms now. I can try factoring by grouping, right? I know it's going to work because I did it on purpose like this, right? What's common in the first 2 terms? 2x. What's left over if you factor out a 2x? X plus 2. What's common in the second 2 terms? -1. If I factor out a -1, what's left? X plus 2. Do these 2 terms right here have a common factor? X plus 2. What's left over if I factor out an x plus 2? 2x minus 1. Well, if I'm looking for my 3 factors, don't I have them all now? I have an x plus 2, and I have a 2x minus 1. Now it depends on what they're asking. Okay? You have to focus on what they're asking for in the homework. If they're asking for the factors, there they are, and we're done. Okay? But most likely, because it asked us to solve, they're going to ask for the zeros, which means I need to take each one of the factors and set it equal to 0 and solve it. So x equals -2. X equals 1/2. And x equals 3. And even more likely after that, it's going to ask you for the set of zeros, which means it wants this. Yes? Any questions? Do you have any questions about any of these objectives that we've talked about today?